Welcome, GeoTrig. This is section 2-4, Deductive Reasoning. The essential question is if I give you true statements, what can you do with them to make a true conclusion? Let's begin. So this section is kind of neat. It's about deductive reasoning, which is reasoning logically from given statements or facts to a conclusion. So I'll give you some given statements that are true, and you have to use those to come up with some other conclusion that's not listed. And this is the key part of geometry proofs. I start off with some givens, and you're supposed to manipulate those and do other things with that and deduct other things to make some other conclusion. So here's two laws that you can use with deductive reasoning. The first is the law of detachment. So if a hypothesis of a true conditional is true, then the conclusion is true. So that means if P then Q is true, and P is true, then you know Q has to be true. So if I say some hypothesis and you know that's true, you know the conclusion is going to be true. That's all that's saying. So we can break that up into parts. So what does that mean? Well, if a student gets an A on a final exam, then the student will pass the course. Don got an A on his history exam. What can you conclude from the given true statements? So the first statement is some conditional I came up with. If you get an A on your final, then you'll pass the course. And the second statement is part of that. Don got an A on his history exam. So you can conclude from detachment, well, this is the first part of the hypothesis. Don got an A, so the conclusion is Don will pass the course. So you can conclude Don will pass the course. Because if the first part of the statement is true, then the conclusion, if the hypothesis is true, the conclusion has to be true. So Don will pass the course is the conclusion. All right, the other law is the law of syllogism. So this law says if P then Q is true, and if Q then R is true, then if P then R is true. So basically it's connecting those into one big conditional. It's similar in math where if I said if A equals B and B equals C, then A equals C. It makes that jump from A to C. It's the same kind of concept. So let's see that in action. If a figure is a square, then the figure is a rectangle. Okay, that's true. If a figure is a rectangle, then the figure has four sides. And that's also true. So what can you conclude from the given information? Well, I have figure is a I know that from the first statement, the conclusion is figure is a rectangle. And the second statement, the hypothesis is if a figure is a rectangle, then the figure has four sides. So I can conclude, I could skip the middleman here. And I can go, if a figure is a square, then the figure has four sides. The figure. So this is using that law of syllogism. It's just connecting the start of the first hypothesis with the conclusion of the second one. All right, let's try some examples. So example number 1, pause the video. All right, let's try this. What can you conclude from the given true statements? If two angles are adjacent, then they share a common vertex. Angle 1 and angle 2 share a common vertex. Okay, so it looks like law of detachment here. So we got the first conditional, if two angles are adjacent, that's the hypothesis, then they share a common vertex. So that's the conclusion. Okay, we can also say, well, wait a minute. If we have angle 1 and angle 2 share a common vertex, then they have to, no, but see, now can we conclude anything from there? So this information, you might do this fast and say, okay, we can say they're adjacent. But is that true? Not really. They share a common vertex. But we can't conclude anything from this, because this could be angle 1 right here. And we could have angle 2 right here. These both share a common vertex. They are not adjacent to each other, because they have to share a common side. So this isn't necessarily true. We have to say, the way the law of detachment works is if the hypothesis is true, then the conclusion must be true. We're saying the conclusion is true. They're given that this is the conclusion. This doesn't mean my hypothesis, the first statement, two angles are adjacent, has to be true. So what can I conclude from this truth from the given? Nothing. Can't conclude anything. It's a trick. All right, example 2, pause the video. Okay, what can you conclude from the given info? If you do gymnastics, then you are flexible. If you do ballet, then you are flexible. All right, So this looks like I have two statements that maybe I can use that law of syllogism. But if you do gymnastics, then you are flexible. But this second statement, flexible, is still the conclusion for both of these. So what can I conclude from that? Well, I can't say, well, if you do gymnastics, you do ballet, because that's what it kind of looks like. But that's not what's going on at all. These are two conclusions. So I can't conclude anything from this. So this is, again, a nothing. Because I can't say, if I do gymnastics, I do ballet. Does that make sense, even if you think about that logically? Just because you do gymnastics doesn't mean you do ballet, or the converse of that. So that doesn't make sense at all. Whenever you're doing these things, ask yourself, does it make sense to even say that? Just because you're following the formula, just think about that, and does it make sense? Because whatever statements we write have to make sense. All right, pause the video. What can you conclude? All right, what can you conclude from the given info? If a whole number ends in 0, then it is divisible by 10. If a whole number is divisible by 10, then it's divisible by 5. Well, there's the connection here. We got a conclusion, it is divisible by 10. And we got a hypothesis that says it's divisible by 10. So we can make a conclusion using the hypothesis of the first and the conclusion of the second. If a whole number, so if a whole number ends in 0, then it is divisible by 5. And that makes sense, right? So if you think about that, if a whole number ends in 0, like 10, 20, 100, these are all divisible by 5. That's something we include, and it's something that makes sense. So this is all we can conclude. That's it.